Hello everybody, today I will talk about our dendrites and diffuser project. My name is Zhu Jiahao and my partner is Yang Han. And first we will talk about the concept of the dendrite and diffuser. Actually, the dendrite is the link between neurons in our body, and we can see this picture here shows the schematic of the dendrite. Actually, this is a very big channel for some biological signal to be propagating, actually using diffusion, and along the channel, along the dendrite, there will be small channels on the wall, which is synapses, and the synapses came from different other neurons, and the signal will transmitted from other neurons to the synapses and actually getting to the dendrite and participating in the transmission. So we model it with the picture on the right side here. All the vertical transistor here is a model of the neural channel along the dendrite, and its gate mechanism is the same as what we used in HS neuron, and the horizontal transistors are modeled as actually the loss or dissipation of energy along the dendrite. So all the horizontal transistors should be working in triad region as a resistor. And then if we input a signal from the first input, actually the signal will be propagating to the first output and second output and third output. So if we only input one input here and basically floating or shut down the other top transistors of input 2 and 3 and 4, we will see the same waveform from 4 outputs, but the waveform will be in different amplitude and will have some latency. So first we will take a look at our one input result, and our input is two triangle wave, and our output for the left side, the yellow one is our first output, the blue one is second output, and for the right side, the yellow one is third output, and the blue one is the fourth output. Actually, we got a rather fair result since the amplitude of the first and second and fourth channel is keep decreasing, and it is what we need because during the propagation, the amplitude of signal will be decreasing since the resistor actually acts as some losses to that signal. But our third channel is rather high. It is because of some mismatch since we put all the floating gate OTA the same parameters. So actually we cannot make sure that the FTOTAs have the same output gain. So it is hard to say that the actually output signal will have a relationship like what we get here. And then we got two inputs from the input 2 and input 1. Both inputs are the same as what we have in one input scenario. And we can see there's a propagation example since look at the first channel here. When the first high amplitude went through, then this high peak is from the propagation from the second input, and we can see both the two peak in one period in 4 channels. If we put 4 inputs with each input have a 10 points delay, what is shown here to the 4 inputs node, and because the delay is very small, so basically all the signal will add up. So we can see a very huge bump here, and actually we cannot see some kind of thing like a flat or a drop, because when one signal is going down, the other signal is going up, and basically just boost the signal up. And if we have a 15 points delay, then the story will be different. So we can see here for the first output, actually we have 1, 2, 3. The fourth one is not clear. It may be because of the mismatch and other reasons. So you can see here, actually, when the first input is decreasing, the second input is not increasing so much, so there will be somehow there will be a flat area and then goes up again. And you can see, especially for the fourth channel here, we think that the first peak is actually the biggest, and this channel is not responding to its own stimulation very well. So you can see every channel may have a different highest point due to the propagation. And if we put a 100 points delay, then you will see a flat and decreasing, since when the first signal is propagating through, the first channel is actually going down, then at that time the second channel's propagation will come to the first channel, which will keep increasing against the decrease of the signal of the input of the first channel. So we can see a decrease here and then increase again. This is because the delay is much more than the 15 points, so it has a decreasing period. This is our result of the dendrites. So thank you for listening, and good luck and have a happy spring break. Thank you.